All right. With this one, there are actually two ways we can do it. We can either first convert it to polar form and then use de Moivre's theorem to do the power, or we can expand it using Pascal's triangle, keeping it in Cartesian form, and then simplify that. So we're going to do both methods. The first method, we're going to use de Moivre's theorem. So let's just write a little thing there, convert to polar form and use de Moivre. Okay, so let's have a look. We're going to, firstly, let z equal 1 minus I. Okay, we're not going to worry too much about the expansion yet. We're going to change or convert z from Cartesian form into polar form. And we're going to draw a little diagram. So we've got 1 and minus I. So this is where z is sitting over there. And that is going to be my angle. My modulus of z is going to be my a squared plus b squared, which will be my square root of 1 plus 1 squared negative 1 squared, and that's going to be square root of 2. And I need to get my angle, and be careful, we know that this is in the fourth quadrant, and that means before my principal argument I'm going to have a negative angle. Okay, so tan of theta is opposite over adjacent, and that's going to be 1 over 1, so theta is going to be pi on 4. So therefore my argument of z is going to be negative pi on 4, and so therefore I can say that z in polar form is going to be root 2 cis of negative pi on 4. All right, so now that's in polar form, and they're asking me to evaluate 1 minus I to the power of 3. So what we're looking for is z to the negative 3, which is going to be equal to root 2 cis of negative pi on 4 to the negative 3. And we're going to use de Moivre, so we're going to say use de Moivre. And that says that we're going to have, we're going to expand our root to the negative 3. And then we're going to say cis of negative 3 times negative pi on 4. And square root of 2 to the power of negative 3 is just going to be 1 over 2 root 2, because it's root 2 times root 2 times root 2, and root 2 times 2 is 2. And that's cis of 3 pi on 4. We need to look and see, is this in our domain? 3 pi on 4, yes it is, so that's all good. But now they want us to give it in Cartesian form, so we're going to convert it back again. So cis stands for cos plus I sine, so that means we've got 1 over 2 root 2 cos of 3 pi on 4 plus 1 over 2 root 2 sine of 3 pi on 4 times I. And now I need to go back to my methods knowledge, because 3 pi on 4 is in my second quadrant, which is over here. And in that quadrant, sine is positive and cos is negative. okay? And my base angle is pi on 4. So what I've actually got here then is negative 1 on 2 root 2 cos of pi on 4 plus 1 on 2 root 2 sine of pi on 4 times I. Alrighty, now cos of pi on 4 and sine of pi on 4 are both root 2 on 2. So what I've got is negative 1 over 2 root 2 times root 2 on 2 plus 1 over 2 root 2 times root 2 on 2i. Alright. And now I can cancel out and work through. So I have negative 1 on 4 plus 1 on 4i. All right, and that's in Cartesian form, and that is z to the negative 3. Let's have a look at what we would do if we were going to use Pascal's triangle. Now, you've learned about Pascal's triangle before. It looks like this. And for a cubic, we would have 1, 3, 3, 1. So I'm going to say, well, let's let W equal my 1 minus I. And we're going to make it to the power of 3 rather than to the power of negative 3. Because what I'm going to do, if you have a look here, it's 1 over 1 minus I to the power of 3. Okay, so then we're going to say W is going to be 1 times 1 cubed times negative I to the 0 plus 3 times 1 squared times negative I to the 1 plus 3 times 1 to the 1 times negative I squared plus 1 times 1 to the 0 negative I cubed, and that's going to give me 1 minus 3I and then negative I squared becomes I squared, which is negative 1. So that becomes negative 3. And then negative I cubed becomes negative I times negative I, which is I squared, which is negative 1 times negative I, which is positive I. So positive I. And so W becomes negative 2 minus 2I. But we need 1 minus I to the negative 3. So that means we're actually wanting 1 minus I cubed to the negative 1. So we're actually looking for negative 2 minus 2I to the negative 1. And when we look at that, we're looking at 1 over negative 2 minus 2I. And we don't like having complex numbers in our denominator, so we are going to rationalize that. So we're going to multiply by negative 2 plus 2I over negative 2 plus 2I. And that gives me negative 2 plus 2I over 4 minus 4I plus 4I minus 4I squared, and that gives me negative 2 plus 2I over 4 plus 4, which is 8. And when I simplify that, I get negative 1/4 plus 1/4I, which is what we had previously.